Hello friends, today's question. A rod of length 50 cm is pivoted at one end. It is raised such that it makes an angle of 30° from the horizontal as shown and released from rest. Its angular speed when it passes through horizontal in radian per second will be, taking G as 10. So this is a rod making an angle of 30° with horizontal, and we are supposed to find out what will be its angular speed when it passes through the horizontal line. So first of all, we are going to use in this you can say conservation of energy. So let us find out what will be its potential energy at this position when the angle is 30°. We can say determining the initial potential energy. Initial potential energy, that is at angle of 30°. So if L is the total length of the rod, then we can say the center of mass will be at a distance of L by 2. So this is our center of mass, and the center of mass is at a height h from the horizontal. So we can say the center of mass of the rod is at a distance of L by 2 from the pivot point. From the pivot point, and let us call this point as P. And if h is the height of the center of mass, if h is the height of center of mass, then h will be equal to L by 2 sine of 30. Total length is given as 50 centimeters, so this will be 0.5 meters divided by 2. Sine 30 will be your 1 by 2, and this comes as 0.125 meters. So this is the height of the center of mass. Therefore, the initial potential energy let us call that as U initial, will be equal to mgh. H we already know, so we can say U initial will be equal to mg multiplied by 0.125. So we got the initial potential energy, and it is said that P is the pivot point, so the rod is going to rotate about this pivot point. So we can find out the moment of inertia of the rod about the point of pivot, that is point P. which will be moment of inertia of the rod about one end. So we can say I end will be equal to 1 by 3 and ml square. Now we can use the, you can say, conservation of energy. Conservation of energy. So it is given that the rod initially is at rest, so it has only the potential energy. There will be no initial kinetic energy. You can see initially the rod has only potential energy and no kinetic energy. And as the rod is going to pass through the horizontal axis, the entire potential energy will be converted into kinetic energy, and in this case the kinetic energy will be rotational kinetic energy. As the rod pass through the horizontal position, all initial potential energy will be converted into rotational kinetic energy. Rotational kinetic energy. And rotational kinetic energy let us call that as K rotational, will be equal to half I omega square, and I is your I end, that is moment of inertia about the end, and omega is the angular velocity as it crosses the horizontal position. So we can say conservation of energy states that U initial will be equal to K rotational. U initial is mg into 0.125, and this comes half I end omega square, or we can say half, and this is 1 by 3 ml square and omega square. Mass and mass cancels out. G is supposed to be taken as 10, so we can say 10 multiplied by 0.125 is equal to, this will be 1 by 6 multiplied by L square. L square will be 0.5 into 0.5 multiplied by omega square. Or we can say that our omega square is equal to, this will be 60 multiplied by 0.125 divided by 0.5 into 0.5 and this will be coming as, let me solve it. This will 60 into 125 and divided by 1000 into 5 divided by 10 and 5 divided by 10. 0 0 0 0 goes, this also goes away. This will be coming as 25 and this goes by 5. So this will be 6 into 5. So therefore the angular velocity omega will be equal to square root of 30 radian per second. So this is the angular speed as it passes through the horizontal. This is the angular speed as rod passes through the horizontal. And if we check the option available to us, option number B is the correct option. Option B is correct. Yeah, this completes the question. Thank you.